All right, welcome back to the Grand Solar Minimum. Today is Saturday, excuse me, April 12th, 2025. Thanks for tuning in to this broadcast of the Grand Solar Minimum channel, right? So, let's start with our space weather. First of all, we'll get right into the stats. Yes, no huge flares. Not surprising either, guys. You know, Take a look at our sun right now. Solar wind speeds of 472.7 with a density of 2.59. Sunspots number 120 is the smooth sunspot count, which is trending towards below 100 within the next few days. I'll show you here in a bit. Our KP index is sitting at a 2.67. Our 24-hour max is at a 4.33. Cosmic radiation dosage rates are at negative 7%. And I want to mention that for a minute because we've talked about dosage rates in the past, how high they were during a minimum, and how low they can get during a minimum as well. Oops, sorry about that. And I think it's interesting to note this broadcast is being inspired by a particular forecast. I remember it. In fact, I think we'll go ahead and play that interview live. We'll just rebroadcast it while we're doing the show. I don't know where the exact part was, but we can just watch it. It's been a long time. We'll let this stream run for a while. Nobody's really here yet anyway, so Scrappy Cat just giving us an update that we are at a KP4. So let's go ahead and check that out. But cosmic radiation dosage rates, usually in maximum, you're going to be in the double digits, negative 14, negative 15. The fact that we haven't even touched that is in itself remarkable. Let's go over to spaceweather.com real quick and get that update. We'll refresh this as it's changed since the broadcast. No, not being reported yet on spaceweather.com, but spaceweatherlive.com sometimes is quicker. So we're not seeing that. But thanks for the update, Scrappy. We'll continue to watch that. Weekend Aurora is saying today a G1 is possible. So it could be that CME that is arriving that is causing this increase in KP indices. Hey, Mutant Ralph, whatever your last name is, you just won a prize. Apparently, you're too young to know what the cover photo is and the way the guy talked. So, no judgment. It's okay. Wow, what happened here? Popular astronomy. Yeah, I don't want that. So today's episode of the Grand Solar Minimum is mainly going to focus on the why, the how, all that good stuff. There is a good look right now at the sun and the black area here, and I'll show you what I'm talking about so nobody thinks I'm racist. This area right here is what's approaching the eastern limb. Okay. So we will see at this point, this trend is showing us more of the same lighter sunspots, weaker outputting sunspots, not a lot of facula. Facula is the bright stuff right here. We've talked about this before. Increased sunspots, increased facula. There are papers out there now suggesting that the reason why temperatures can get warmer during maximum is because the facula is actually enough output to trump the sunspot. Now remember, the sunspot is a dark core. It doesn't emit anything out of it. But if you have lots of facula, like this right here is nothing. Like we're supposedly at a maximum, and the whole part of this sun should be lit up with facula, but it's not. We just got a little bit here, a little bit here, maybe some weak stuff here. But overall, we have 120 on the smooth count for sunspots. And it's interesting to me because we're supposed to be at a maximum. In fact, what I want to tell everybody is that our maximum got here early. Now, remember, when a solar cycle happens, usually we see about 4 years before we see the peak. Except that didn't happen. We got our peak about a year and a half early. And I know there's a lot of other people out there that will believe me in that one, or they're at least with me on that. I'm showing this screen right here because I want you guys to take a look. I will show you exactly where the peak is, and we'll line it up. The peak, which I believe is this area right here. And as you take the arrow down, we are smack dab in some part of late 2024 is where the peaks, and then the beginning of the maximum was slightly before 2024. Now, we weren't supposed to see this part until 2025, according to the folks who oppose the idea of a grand solar minimum. Solar cycle started in 21, moved all the way 4 years later. The maximum should be starting sometime around 2025, 2026. Instead, we're already past the peak. More proof that we're past the peak. It's even in an article that a paper that is trying to dismiss the idea of a grand solar minimum. Let's take a look at this. This was our peak. This is where I'd say the maximum begun, right in this area. You know, of course, the minimum short-lived ramping up of solar activity, but we started to really see the beginning of this maximum really start to get its act together right around here, and that's around 2024, mid-2024. The peak has happened. As we can see, we are now seeing this sudden decrease in sunspot activity. Okay? I'm going to pause that for a minute because this paper is suggesting that this is the end of a minimum type era and that the grand solar minimum is not going to happen. A study published on March 2nd, 2025 by Calvin Adams and colleagues presents evidence that the minimum of the centennial Gliesberg cycle has ended. I'm not quite sure, but that's what they say. The Gliesberg cycle is an 80 to 100-year modulation of the sun's 11-year sunspot cycle. Researchers identified the most recent CGC minimum spanning of the solar cycles 24 and early part of 25 with a sharp reversal in proton flux and rising solar irradiance. Now, folks, the rising solar irradiance during solar cycle 25, as it has been, is heading into the maximum during the early part. And we'll report on TSI here in a minute, too. During solar cycle 25 signals the end of the minimum and the onset of more active solar phase. Okay, let's continue to read. A lot of ads here, guys. I guess it would be useful to have a subscription of this because I don't like all the ads. Using data from NOAA, POES satellites, NOAA 15, NOAA 19, the team examined inner zone proton flux over the South Atlantics. All right, that anomaly that we've had, the collapse in the magnetosphere. Proton flux increased significantly during a period of declining solar activity. Folks, this article is deceptive. The reason why the proton flux increased in the South Atlantic anomaly, the reason for this SAA in the first place is due to a collapse in the magnetosphere. In other words, the weaker the magnetosphere is, the more cosmic rays, cosmic particles, whatever space weather that wants to come in is coming in, and especially if you don't have any protection from the magnetosphere. So they are purposely citing this time exactly when we started seeing this, 2022 to 2024. The trend reversed sharply, suggesting a possible turning point of the GCC. Listen, CGC, I'd rather just call it the Centennial Gleesburg Cycle. Let's just go with that. Guys, my goodness, if anybody's been paying attention to this channel for the last 10 years, if anybody's been paying attention to this, we know that when you have a collapsed magnetosphere, even a crack in the magnetosphere, more particles will enter the atmosphere. So proton flux increased significantly during this period of time because of the collapse of the magnetosphere. And here's the sad part. We are not talking about the magnetosphere collapse in this area. Look at this. Nothing. Not a word about it. They're just taking this one, and this is my point. This is why I made this video today. You got a lot of people who saw this article, and I'm not going to say any names. I did watch one particular channel's video of him saying that the GSM is no longer happening. I'm sorry to report this, and I know a lot of you are mad at me for this, but it's not happening. He takes one paper out of hundreds that say otherwise. And these are the type of people you have to watch out for, folks. They're just trying to be disruptors. Just like when you see trolls on your channel. No. I'm gonna allow this comment here by Summer BC because that's a classic Yosemite Sam comment. I love it. Thank you. I can hear him say it as I'm reading this. I hear the Yosemite Sam, great horny toad. That's a terrible Yosemite Sam impersonation. But anyway, back to what I was saying. This person took one misinformative paper, not even talking about the magnetosphere issue that we had in this area where the SAA was, okay? But anyway, even if it was mentioned, it still wouldn't matter because this is one paper out of hundreds that say we're going to go into a grand solar minimum. Now, they're talking about observational data compared with the theoretical model. Example from 2007, updated in 2019. The model includes proton sources such as cosmic ray albedo, neutron decay, and loss mechanisms, if I can talk, like atmospheric drag. Simulations closely match the observations after a minor adjustment. The study found, oh, I didn't do that. The study found that the proton flux declined more rapidly in the NOAA 19 data, which operates at 870 kilometers, that's 540 miles, compared to the NOAA 15 at 510 miles. Solar cycle 24 was the weakest in over a century, actually 150 years, but who's counting? Coincided with the minimum phase of the Centennial Gleesburg cycle. Oh, wow, I don't know why this is moving, folks. Kind of freaky. I'm not touching this. This aligns with historical patterns identified by Finyamin Rizamakamam in 2014, who studied the earlier minima in 1810 through 1830. But see, that was during the, correct me if I'm wrong, isn't that during the Dalton minimum? the 1900 to 1910 is the Gleesberg. At least that's how I read it. The Little Ice Age was in the 1600s and ended later 1600s, early 1700s. And then we had not a grand solar minimum, but another minimum cycle that was like the Gleesberg that we had back in 1910. And the reason why that's important is because of, what do you call it? Well, in 1911, there was a historic flood in Dayton. And low solar activity makes a weaker magnetosphere. Once again, high cosmic radiation also causes a lot heavier precipitation. Cosmic radiation is the fuel, is the steroids to our weather. That's how you got to think about it. We are coming out of the grand maximum. The peak of the grand maximum. Let me get a chart that shows. There is a chart in this article, I believe, that shows us the solar cycles. Ah, here it is. Let me zoom in a little bit more. Yeah, okay. So right here, guys, if you're on a phone, I'm sorry, this is small, but this is where, right here, 1910, this is where the Gleesberg minimum ended, right around this area. We started maximizing once again, and now we are heading down. Now this only goes to 2000. I don't know why. Again, they're hiding information to make it look like their theory fits. All right. But this was our last grand maximum, somewhere around 1950s through the 80s and 90s and into the 2000s. That's when we had our peak solar maximum. Grand maximum was right here. So coming out of that, and now lining up with a grand solar minimum. Last time we had a grand solar minimum was back in the 1600s, which is roughly about 410, 15 years ago. Right in line with where we are heading. So I find this article very, I find this paper, I find this information very deceiving. They don't talk about the magnetosphere. They're not being accurate on the timelines and what cycle was where. Hey, you know what? I'm not lying. Let's go to the grandsolarminimum.com. It'll show you. I love this website. I wish we used it more. Sad. I'm sad that we don't. We have down at the bottom of the main page, we have exactly the cycles listed off. Yeah, somebody came over to our page and was all blah, blah, blah. Okay, this is a better image of the maximum, guys, and the minimums. This is better. Okay. So, right here is where the Gleesberg happened. Right around the late here. This cycle was definitely lower. This was our Dalton minimum, grand maximum, Gleesberg cycle minimum, our grand maximum. I don't know what we are arguing about, guys. I mean, this chart right here, and this is courtesy of the work of David Birch. Yes, it stops in 2017. That's when this was made. We need to update our graphics, but still, like we're definitely in a downward trend in solar activity. And maybe the grand solar minimum starts here, and it's not unheard of. I mean, to have a blip in the minimum period, to have a sudden action of sunspots in a solar cycle, even in a downward trend. And I can't believe that we're not seeing how low the solar activity, the sunspot counts. Look at this. These two cycles right here are not even close to what this is. So this is reflecting the decline to show that we're about to hit something like this or even worse. Let's keep going. All right, here we go. So this one right here is the best probably for this. Zoom this in a little bit. And we got it because we really need to pay attention to this, guys. All right. Dalton minimum was right before at least the bottom part of the minimum was around 1810, right? The Gleesberg cycle was early 1900s, right here. And then we started to see the uptick. We had our maximum of sunspots after the 60s. And then we started seeing things kind of look, we even got this false, like, oh, we're going to start really dropping. And that's the decade around the 70s where everyone was talking about the next ice age. They thought, we're plummeting. Sunspot information is showing us that was a sharp decline. And it was a sharp decline. But as you see, the next cycle is exactly where it probably should be when it comes to peaks. So there is such a thing to have anomalies during these cycles. Again, no one's trying to be spot on perfect on the prediction of when these cycles arrive and when the lowest of the sunspots. This is all just educated, theories and mathematic problems that are being solved here to show this. But again, this paper has basically lied and told you that the earlier minima in 1810 and 1900, these were the beginning of these transitions for the centennial Gleesberg cycles, and that's not true. The Gleesberg cycle, the Gleesberg minimum, they called it, was in the 1900s, 1910s, a little bit after that. But 1810 to 1830 is clearly in the Dalton minimum, and they show the proof right here. Oh no, that we were on my page. Yeah, they won't show you that. See, the data doesn't go back past 1980 here. See, nothing showing anything before anything that's relevant, which is very sad. Very, very, very sad. Dalton minimum. You can see this is the magnetics of the sun. And if they would go back further, you would see how weak it was during the little ice age. But again, they don't want to show anything that relevant. Here's a better look at where we are as far as in these cycles. As you can see here in the 1600s, I would have to assume this is somewhere around the 1600s. My goodness, all these ads. That's on our page. I'm sorry, folks. I was getting ready to yell at watchers. That's my page. Whoops. But no, grand maximum was right here from the 60s till about 2000, and then we started seeing sun spot numbers take a huge plummet. And like I promised, we do have them listed down here at the bottom. The different minimums, the different maximums. The modern maximum, they're saying 1914 to 2007. Okay? That's about accurate. So I hope that answers your question. Sorry it took me so long to get to that answer. There's just so much to talk about, guys. This is not anything that's overnight. This isn't anything that you can explain in a half hour or 45 minutes. I've only scraped the surface just by talking about what I'm talking about right now. All right. So, with that said, that paper, and the thing that drives me nuts is that Valentina Zarkova was ridiculed so much for a calculation being slightly off that had nothing to do with the outcome of the forecast. They're citing that because there's been stronger activity, that this is the cycle that's breaking up the grand solar minimum. I'm telling you right now, this is an anomaly that that we are witnessing. Oops, sorry about that. I'm having a grand old time here. We can already see the steep decline. Now, back to that. Who predicted the steep decline? And I'm going to pause this for a minute because Mari's going to walk in the door and my dog's going to go nuts. False alarm, that was my son. But Mari's due home any second, actually. So I have an idea. We haven't had some chat time anyway. we got about 400. No, if I wish 43 people. 400 would be awesome. Like, how do we make that happen, guys? Like, let's get some more people on this chat. Share it to your social media platforms like Twitter and Truth Social, please, because I think this information is very important. And just to kind of expand on Valentina Sarkova's work, she recently was in communication with Mari. I don't know if some of you know this, but Skype's going away. So, with that being said, Mari just wanted to reach out to make sure that they had contact. And, you know, Valentina is aware of the fake news that's being spread around. This is relevant right now. And she has not wavered away from, we are still heading towards a grand solar minimum. She is not backing away from that one bit. So we may have to do an update interview with her. But look at the trend. It's steadily continue. There's the anomaly, or I should say. But if you look at where this cycle is, it's slightly lower than 23. It's lower than 22. It's lower than 21. There is that other blip. So this is a blip, and that's a blip. Okay? Point is that all signs are still pointing that solar activity, even though we had really low activity in solar cycle 24, it's still trending downward. In fact, look at the sharp decline that this chart is showing. Barely. Hang on. There's the mute I need to do. Mari's home. The dogs are barking. Hang on. Yes, Melody. Absolutely. Instant gratification. All right, sorry for that. We're back. Mari is home, so the dogs have to show her love, as always, which is fine. You know, they love their mommy. But anyway, that was weird, wasn't it? Jake said mommy on a Grand Solar Minimum channel. But we still see this constant decline. Okay. Nothing's changed course, folks. Nothing dramatic is happening. We're in the maximum early. We're starting the decline out of the maximum. That's obvious with the sunspot numbers that we got. TSI levels also will indicate that we are definitely flirting with lower numbers. Now, there's fluctuations right now, and TSI takes a long time to go up and down. We're not breaching the 1362 squared watts per meter. It's staying above that. We did have it breach that, looks like back in January 22nd, my birthday. That's a sign from the cosmos, isn't it? This TSI was 1361.7. So that was the lowest point so far this year. It was on my birthday. Yeah, there you go. There's my vote of confidence. Yeah, Lisa, I turned off the mic for a minute. I told you guys I was gonna push mute because the dogs. Anyway, I don't know why Skype's going away, Juana. Mari informed me of that, so maybe I'll get more information about that when it's going to happen. But nonetheless, as Valentina has said before and is saying right now, there is still an oncoming grand solar minimum. That's not changed. TSI has been all over the place since 2024. The freak incident where it dropped well below 1361 watts per square meter. And the peak is it's already happened, as we are now watching a decline in TSI. We are on the other side of the peak, getting ready to go down that cliff. And you want proof? You want proof? I'll give you proof. Let's sit back, get your popcorn, ready. Get yourself a drink. I'll look at some questions real quick, because I'm going to queue up a video and we're going to watch it. And she's going to talk to you about how it's going to happen, when it's going to happen, and even throws in that we are going to see warming. We are going to see warming by 2021 or 2100. It's in this. I think it's in this one right here. No, stop it. Stop. I don't even know where my own content is. Sad. This is not the. This is the. Oh, yes. Remember all the super grand solar minimum stuff? My God. That was crazy. Trying to explain that. Alright, guys. I'm going to chill in the chat with you for a minute. But let's watch this presentation. This was a good one. One of our better interviews with Valentina Zarkova here on the Grand Solar Minimum channel.
Today we have a very special guest with us, Dr. Valentina Zarkova. She is a professor of mathematics at Northumbria University, also a PhD in astrophysics.
Can you guys hear okay?
A recent paper that she has had published in Nature.com as of June 24th, 2019, Oscillations of the Baseline of Solar Magnetic Field and Solar Irradiance on a Millennial Timescale. Valentina, how are you today?
I'm doing very well, thank you.
Great to have you on. I know you and Mari have had several conversations dealing with this paper.
I look like a turd in those
so
glasses.
Today we thought we'd bring you on and once and for all kind of explain a bit about the paper. And there seems to be a little bit of confusion out there, not from this side. We are totally clear on what's going on here. So basically, if you wouldn't mind, I guess we could just start and talk a little bit about the process. You came out with the presentation in October. This was a long process, as is the peer-reviewed journals are. But if you could just kind of take us back to how things kind of started and got to where we are right now with the paper.
Yeah, first of all, can I tell you that I wasn't so busy with the paper, but with the exam board and marking, finishing, and doing evaluation of my modules. Only now I'm getting towards the paper because it will be reported next week on the National Astronomy meeting. So this is why we eventually prepared the press release, and hopefully it will be going out either tomorrow or Monday on our side and the Royal Astronomical Society side. So we're working on it, and so this is what I started doing. And of course, I was involved with this unexpected, because we didn't have press releases. I thought people wouldn't see yet the paper, but it turned out some people read the journal much more extensively. And so obviously I got involved in some interviews. Actually, it was radio from Manchester who got me on Tuesday even.
I heard that.
Guys.
I heard that. Very good interview there.
Yeah, it was a very good guy, actually. And he interviewed Akasofu. He knew the problem. So obviously it's not only us who understand the problem, there are many others. So definitely this is the happening. So it's nice to consolidate alike people. I really was pleased to speak to the person, I had to say.
So let's get right into it, I guess. First subject I wanted to talk to you about was the super grand solar minimum cycles. I think a lot of folks might have misinterpreted what exactly the definition of the super grand solar minimum. So if you could just kind of tell us about these super grand solar minimum cycles and how this came about.
Okay, so let me explain that the solar activity, this is something which is happening on the sun. And what we done in the previous paper, we detected these double dynamo waves which interfere and produce this grand minimum every 370, 400 years. So this is fine. This is what happened on the sun. On the way, while we're working on this, we managed to derive the formula for these waves. So this makes our life much easier because now we can calculate this wave as long as we wish. And in the last half year, we calculated it backwards to 120,000 years. So, and when we did it, we discovered that when you look at the summary curve which describes solar activity on the sun, there are patterns which repeat every 5 grand cycles. So every 5 grand cycles we have first cycle slightly higher amplitude, narrower cycle. Second cycle amplitude lower, cycle wider. The third cycle has something also particular. And when you produce this for 20,000 years, you see how you can split them into particular parts,
okay,
combining 5 cycles, which the shapes repeating each other. So this is the first visual view at this cycle, which really surprised us all. So we thought, oh, what is going on? So we get this 120,000 years of data. So we decided first to see what is this cycle. At that time, it was visual definition, about 2,000 cycle.
I think right there, it helps me understand with the whole super grand solar minimum. Looking back at this video, this was done in 2019, and you can see in the video that she shows the amplitude of each cycle, and you can see it where it's, it's slightly down. Here, I'll try to get back to this one right here. Let me get the arrow out. Since the second and third grand cycle, remember this is a 5 grand cycles is a super grand solar minimum, and it's measured in 5 grand cycles. You can kind of see it was a weaker amplitude starting to get stronger in the final one. So it goes from down to up to down, and it's going to go up again, but not during this grand solar minimum. So the amplitude is still low compared to what's going to happen in the next grand solar cycle.
Oh, what is going on? Oscillations of the 11-year cycle, because the amplitude is biggest. So we wanted to suppress. When you run 1,000 year, it becomes very average magnetic field. And we also played with the 20,000 year filter. So you again suppress all the oscillations. And when you're playing with 20,000 year filter, we discovered this 40,000 year oscillation already seen in our curve between 6. It is figure 1 bottom, which shows you 40,000 years cycle, which is actually, it is the cycle, Milankovitch cycle,
gotcha,
because of the Earth's obliquity.
Yes.
So the Earth's orbit is inclined towards the ecliptic. Now it's 23.5 degrees, but it varies 22 to 24.5. And we discovered that indeed we see in our curve this change of obliquity within 40,000. The period is, Milankovitch says, he calculated 41,000 years, and we see it in our curve. Suddenly this clicked that, oh, obviously our curve has not only solar activity, but because we observe this activity from the Earth, Wilcox Solar Observatory is based on the Earth at Stanford. So obviously we cannot avoid orbital motion effect on this. So we said, oh, what can we see? Maybe these 5 cycles repeating each other, maybe this will be another orbital effect. So this is what we played with the filter about 1000, and we discovered this very clearly. The cycle of about 1150 plus minus 95, so we say 2100 years, which came with very high accuracy. So really surprisingly, for all 120,000 years, we got this cycle oscillations, but the magnitude, of course, of these oscillations were by order or even 1.5 order of magnitude lower than oscillation of the summary curve of magnetic field during normal cycles, because it includes solar activity with the big numbers. But when we suppress these big numbers, we discover these oscillations, which is basically of the zero line of magnetic field. So like if you have cosine function, cosine goes from 0 to 1, and then from 0 to -1, and zero line is when y equals 0. In our case, this y equals 0 turned out to be also a little bit fluctuating curve. So it is not exactly straight line, it is like slightly waving.
Right.
So this is what we discovered, that this zero line like trembling, but it trembled in very organized order within period 2000 years. So at that stage, we of course be very puzzled and started looking what people had, because people are very smart and they already probably look at something. They couldn't explain it properly, but they had intuitive perception they should be right.
Right.
And we found this solar inertial motion, which was very actively promoted by Karvatova from Czech Republic, from Ondřeje, in 80s, 90s, even 2005. She still published, probably now she retired. Before that, in 70s, it was Fairbridge and other guys who we cited in the paper. They first calculated this solar motion, that it turned out that our sun, would they tell us the story about solar system, how it was formed, and the sun sitting in the focus of the ellipse and planets rotate around it in the same ecliptics. It is a nice story for children. In reality, sure. It doesn't, everything doesn't look like it seems. Because first of all, the planets are rotating with some angular inclination to this ecliptic. So what is for us ecliptics? Maybe not the same for Mars or some other small angles, 5-3 degrees and so on. Plus, what it makes, the large planets, so they somehow rotate, they made the sun so move around the very center of the solar system. So it turns out, because of this deviation of the orbits from the classic ellipses and so on, that large planets impose that the center of solar system is slightly offset from the center of the sun. So the sun is a little bit, can coincide, but can be up to 2 solar diameters away from the center. So basically it moves on the cycle about 2 solar diameters towards in different part orbits, basically rotates around this barycenter. And so do the planets. So they pretend they rotate around the sun, but what the planets do, they basically rotate around the barycenter as well. And this is what creates a little bit confusion.
Okay.
And it turned out that this is the only effect which can explain possibly this 2000 cycle, because Karvatova and then Palush, he was also working in Czech Republic. They calculated exactly profiles, plus the guys from Australia, whom I cited, and the Konus calculation, it was their calculation, orbital motion. So it captures many minds. So basically they calculated that indeed the planets make the sun move not simple in straight line, it just rotates in some like spiral rotation, like we shown in figure 4 in our paper. And because of this one, basically what sun does, if this orbit of the Earth is ecliptical and it should sit in the one of the focuses of the ellipse, the sun cannot sit there. It starts moving either closer to apohelium or closer to perihelium. If it moves closer to apohelium, the Earth's orbit becomes more circular, which means that magnetic field become higher because the Earth moves slower in the apohelium and the spring and autumn equinoxes, and much faster during the perihelium. So this is why we have increased, slight increase. It's only, I don't know, even you can say 1% or 2%, but it's essential that we have slight increase of this magnetic field because of this motion. And then when it moves in some other periods, moves away from apohelium, close to perihelium, the orbit become much more elliptical, which means that we have much smaller magnetic field because this sun mostly sitting in the focus of the ellipse, and because the main part of orbit of the Earth is far away from the sun, so the magnetic field is decreased. So this is basically was the, I think, eureka moment for us, because what they said that this imposes the period about 2,100, some say 2,400 years, period of rotation of the solar inertial motion of the planets around the sun. We got only maximum 2,100, but maybe if you include quadruple components, maybe we will expand it bigger. We don't know yet. At the moment, as you know, our summary curve is based on the dipole magnetic waves produced by solar dipole. So this was explanation. So basically what this paper says, everything which was said about double dynamo is correct, is happening on the sun, it's beyond our control, it's always happening, and we always have this grand minima every 370 years or 400 years, they will be happening. But on top of this, we can't avoid, we can't remove ourselves that we are sitting in the Earth which orbiting around the sun, and planets are orbiting around the sun, and they all telling the sun what it needs to do. And this is reflected on this fluctuation of the zero line. So these are two effects which add together, and nothing we can do about it. We need only to embrace both of them, unless we are planning to nuke large planets and remove them from the orbits.
Right.
This is it.
And you know, and the reason why I led off with that concern of the 2,000-year cycle, I think there's a lot of people that misinterpreted it. The 350 to 400 years, the grand cycles, there's 5 of them in these 2,000-year super grand solar minimum cycles. I think some people are actually confusing the term as if it was going to be a much more intense grand solar minimum, a much colder grand solar minimum. People took that word super and thought that it was being referred to the intensity of this particular grand solar minimum, not that it was measured on a 2,000-year time scale. So that's kind of the reason why I wanted to put that out there, to really clarify for people who may not
The word super is related to the length of this cycle, not to its amplitude, to this increase, because grand cycle obviously has much stronger waves, much stronger activity, because it is real activity, 11-year-old, we can't avoid it. while these 2000 will have tiny few percent of the amplitude of the ground cycle, but it is essential because the sun physically moves closer to us and further it affects our temperature. This is essential why we brought it up.
To clarify,
That was very important. I got to pause this for a minute. How many of you remember when this first came out about the super grand solar minimum? How many remember the mass hysteria of, oh, it's the super grand solar minimum and it's going to be ice age and people are going to die immediately and the food's going to go away and well, Mari taught me not to say those words. I'm asking for keep forgetting about that. Anyway, but no, it was people were freaking out. So when we did this interview with Valentina, I led off with the question of what is a super grand solar minimum, and it was important to me at that time because we were the only ones telling everybody that the super grand solar minimum was not based on amplitude but length. And that's exactly what I was that was one of the things that I was kind of like, all right, thank you, Valentina. You heard it from her. The super grand solar minimum is not amplitude related. It's simply the length. So I think that was an important part of the video, and I apologize for pausing it. There is another spot that I'll probably chime in on as soon as she shows her graph for what's going to happen after solar cycle 25.
for the viewers that had some confusion about whether or not we're going into a super grand minimum or a grand minimum, my explanation to them, and I'm hoping I'm reading your paper right, is that the super grand minimum, the bottom out of that was right before the Maunder minimum, and we are
Yes,
coming
exactly.
up
Yeah.
out of that,
Yeah.
and that is causing that temperature increase.
Yeah, it was a very drop during the Maunder minimum because it was coincidence. It was grand minimum at the same time, and it was
Another important part that Mari brought up, that the peak of these grand solar minimum cycles was somewhere around 2 or 3. And when I mean peak, I mean the lowest part of solar activity. And then it comes back up again. And as Mari suggested, that had something to do with temperatures coming up too. But at the end of the day, the grand solar minimum that we are heading into, none of us will be alive for the next one. That one would be, or actually, no, the next 2 cycles from now. So almost 1,000 years. If we can somehow figure out how to live to be 1,000 years old, that one's going to be a nasty one, right? But no, the point I'm trying to make here is that this information was getting twisted, and on this particular interview, I felt like there was a good explanation for why we saw temperature rise, what the super grand solar minimum meant, where we were in the super grand solar minimum cycle, and I think that was important too. And that's probably part of the reason why this channel has always been the soft landing scenario. What do I mean by soft landing? Well, as we all know, there was famine in the Maunder minimum, and that was a pretty bad time. A lot of illness, a lot of disease, starvation, potato famines. I mean, goodness, if you can't grow potatoes, we got some problems. Where I'm going with this is that we saw a weak grand solar minimum, the Maunder minimum. I'm not suggesting that we won't have a weak grand solar minimum upcoming, but I don't think it's going to be as weak as the Maunder either, just based on Zarkova's answer to Mari on the question of where we are in the super grand solar minimum. And she had confirmed that we were on a not as weak grand solar minimum cycle. So I'm not backing down from it actually happening. I'm just saying it's a possibility that we won't see anything as weak as what we saw in the modern minimum. And that's a good thing, right? We're not rooting for famine. We're not rooting for what we had in the 1600s. Good Lord. Simply because there's more people to feed now. You know, back then, if we had people dying of starvation, the world's population was nowhere near what it is today. Nowhere. Not even 1 billion at that time. So, that's rough stuff. But, like I said, I think that we are going to see some challenges in the upcoming Grand Solar Minimum. I think we're going to see a lot more disasters, natural disasters. The earthquakes are ramping up again, and that is because we are starting to see a shift in the sun's activity. I mean, let's take a look at the sun real quick, and we'll go back to the video here. You can see where the activity of the sun is right now. All right, and it's basically a band. These two bands right here, north and south, almost completely meeting in the middle, which is how we can identify when the cycle is fizzling out and a new one begins. But all this sunspot activity is trending almost directly in the middle of the sun. Now, as I talked earlier about facula, we're starting to see less of that. Sunspot numbers are going down. And also, there's an indication that we are going to continue to see sunspot activity decrease over the next several days based on our grand solar minimum page here. Here we go. So I'm glad we're replaying this video because it's bringing up some good points. Very solid points. And, you know, as far as I'm concerned, I'm not going to do this right now, but let's try to see if I can skim through and find this graph. I know what it looks like, so if I see it, I'm going to stop it. And I don't mean to disrupt this broadcast like this, but there is a graph that she has that shows. Maybe it was a different video. Maybe it was a different video. That sucks. Anyway, you can watch it on our channel in its entirety. Drop a comment and say, hey, like it's a Back to the Future situation. But just because we have one paper out there that tells us different, just one, it doesn't mean anything about changing course on anything. One paper, one person. And I guess it's up to you if you want to listen to that person. Or I'm the kind of person that looks at how many other papers are out there that says that we are.
All right. So today's exciting day basically is over the work of Dr. Valentina Zarkova.
Maybe it's in this one. I think this is like a preview of what the interview is going to go over, but I'm very disappointed about this graph. I don't see it. That's too bad. That is too bad. Nonetheless, one of these days,
last year and going into this year, and I was confident and comfortable.
All right, shut up, Jake. Well, that did not go the way I'd like it to, but hey, you can't win them all. Yeah, let's go back. Keep going back. And you want to talk about cycles.
Got a PowerPoint here for us, so here we go.
Yes, hello everyone out there that's watching the video. I have a lot of information to show you. And I am Professor David Tilley, Global Weather Oscillations Incorporated, specializing in climate pulse technology that I developed right here. And you can get on our websites either through globalweatheroscillations.com, that's our principal site, or globalweathercycles.com. That's a little bit easier to remember. I am a former meteorologist from the National Weather Service, NOAA, and the United States Air Force. Now I'm a senior researcher, meteorologist, climatologist here at Global Weather. 50 years of experience. And not sure how I got that. I'm only 25 years old. Anyway, I have a working partner of the International Hurricane Protection Association. And here at GWO, I created climate pulse technology, and it is based on proven science, the Milankovitch cycles, subset cycles of it. And these are, it's all proven science. It is essentially electromagnetic interactions between the Earth, Moon, Sun, and also solar cycles. Here at GWO, we specialize in hurricane landfall predictions. We predict the landfalls. I have 13 zone predictions from the United States down through the Azores, not Azores, but the Lesser Antilles. And we put out the forecast about 5 months before the season even begins, pinpointing where the landfalls are going to be, based on natural cycles, of course. And we also do El Nino predictions 2 years in advance, and of course our climate change research and predictions. And on our website have 4+ climate videos. Pretty much they're podcast videos such as this one here. Now, what we've been told is global warming never occurred prior to 1850. That's pretty much what the media is saying. We've never had this before. And the thing is, was it caused by the burning of fossil fuels and that increased atmospheric carbon dioxide? We're going to look at all that. Or is it a recurring natural cycle? Well, my helper, very smart helper here on beside me, as we study what's going on, my helper says, my instinct says, use common sense.
There we go.
And this is what we're going to show, common sense. And in the common sense, one question to ask is today's climate change science essentially political science to achieve agendas? This is one reason they don't want you to know that we've had prior global warming cycles. Well, lo and behold, look at this. Number one, back in 990 to about 1100 AD, global warming, number one in this century, or during the past 1,000, 1,100 years. Global warming cycle number one. And there's a global cooling cycle. There's global warming cycle number two. Wow, we've had two of them. There's number three, back around 1300 AD. Global warming cycle number four. Global warming cycle number five. And our current global warming cycle that we're in right now, number six. Again, about 1925, and it's right up through 2024. So we've had 6 global warming cycles during the past 1,000, 1,100 years, and we've had 5 global cooling cycles, and we're looking for number 6. And we will show that a little bit later on. Okay, part 1, I have about 6 parts in the presentation. How global warming temperatures, or global temperatures, I should say, are calculated by NOAA and Climate Prediction Center. Well, one thing that they do is they take the temperatures of the oceans and the land areas around the world, but the oceans cover 71% of the Earth. So that has a big bearing on what the temperature is actually going to be. In this, what I'm showing here, this is January 2024, about a year ago, record cold in the Antarctic. Rest of the area is pretty warm, pretty warm. So global temperature.
I want to back that up a minute. He said that we are in global cooling cycle number 5. The correlation is remarkable. I didn't do this on purpose. I just randomly picked another video to watch. We were talking about super grand solar minimums. There's 5 grand solar minimum cycles within this super grand solar minimum. So just as Mari and Valentina were talking about this one being amplitude as stronger than the one we seen in the monitor, because it's at the very end of the super grand solar minimum. And it's just remarkable. You guys will hear more coincidences, or correlations I should say, with solar cycles and these climate cycles that David shows here in this video. Let's keep watching.
Anomalies above or below average incorporate 29% of the Earth's surface is land, 71% is oceans. And this is January 2025, showing all the ocean water temperatures, anomalies above or below normal. The blue in the center there, along the equator in the Pacific, the blue means it's cooler than normal. We have a La Nina occurring, and we're going to talk about it, La Nina, what that does.
Okay.
But the rest of the oceans are pretty warm. The orange to red, the red area is extremely warm. So you can see the oceans are pretty darn warm. And that's one reason why 2024 was the warmest year on record. Because what they do is they add all the ocean temperatures to the land temperatures, average it out, and this is the graphic they come out with. That it actually warms up the land areas, makes it look even warmer than it really was. And this is going to be a big problem for NOAA and the Climate Prediction Center down the road, right around 2030. And I'm going to show you why a little bit later on in the presentation. They're going to be in big trouble. Part 2, climate change cycles. Going to take a look at the warmest year on record, 2023 through 2024. Earth's natural climate pulse. The Earth, Moon, Sun. Proven science. This is all proven. Interactions between the Earth, Moon, Sun. So essentially what we have is, there's the Sun in the middle, the Earth. As the Earth moves around the Sun, it's an elliptical path where it swings in closer to the Sun every January. That's the closest approach to the Sun. But the overall path changes over the course of time. About every 18 to 60,000 years, we swing out further away from the Sun, thus cooling us down. We enter a glacial period.
Right.
That's what we do. And at the same time, the tilt axis of the Earth changes from 22.1 to 24.5 degrees. That's every 41,000 years. So when you hit the peak of a glacial period, what happens is the axis is up straighter, up only 22-degree tilt. So the Arctic, northern part of the world, southern part of the Antarctic, has less sunshine. It's colder. That's why you go into glacial periods. Now, we as humans require sleep, a good night's sleep, or else we do not function very well. Earth is the same way. It needs long periods of rest or it does not function well. And this is what happens on our glacial periods and global interglacial warm periods that I showed on the graphic on our path around the sun. Here's a nice long global interglacial warm period back 425,000 years. Then we went into a long, deep glacial period, warmed up again 325,000 years ago, 225,000 years ago, 150,000 years ago, and this is today. This is today. We came out of a glacial period 8,000 years ago, and we are at the warm peak of the interglacial warm period. We are supposed to be warm now.
Right.
Not cold. We are supposed to be warm. This is a natural cycle. And as the Earth comes out of the glacial period, this was 10,000 years ago, the blue here means that's the glacial period, came out of the glacial period 7,000 years ago, it was very warm, warmer than today. And this is another cycle. The interglacial and glacial periods cycles are about every 120,000 years. And these are about 1,100-year cycles. Very warm back 7,000 years ago, cooled down 4,000 years ago. And you can see we're on a cooling trend since we came out of the peak of the warm period 7,000 years ago. And here we are over on the right. This is another cyclical warm period that comes every 1,100 years. So we're supposed to be warm. This is another cycle where we are supposed to be warm. It's not caused by human activity. Now, sometimes we require an afternoon rest period. If we've had a hectic period in our life and we're a little tired, take a little nap for a while, snooze. Well, the Earth also requires naps, or it does not function well. So we go into shorter cycles on this. Here's the moon. And at this point, it's at the furthest point from the Earth called the apogee. When it's at the apogee, it has a lower amount of gravitational pull. And these cycles occur as the moon makes its cycle around the Earth. It comes in, and it's also a elliptical path, just like the Earth around the sun. So when it is closest approach to the Earth, this occurs every month, once a month, and even closer approaches on other cycles every year, 4 years, and 9 years, 18 years. These are all cyclical. So when the moon is in closer to the Earth, and this is why you get your big full moon during a month, and the ocean tides are higher. That's because gravitational pull is increased by 30 to 40%. That's big. Now, when it's in alignment with the sun, this is called a perigee syzygy. That even provides more gravitational pull, increased up to 44 to 47%. That is huge.
Yeah.
And this is why you have coastal flooding sometimes along the coastal areas without a storm. That's when this cycle occurs. And here is the new moon. It goes on 4-year cycles, comes down to 28 degrees below the equator, about 28 degrees above the equator. New moon on the left does the same. The new moon can be just as strong as the full moon. Acts like a plunger, pulling and tugging at the oceans and atmosphere. And these strong gravitational cycles expand and contract the outer core of the Earth. The outer core of the Earth can bulge by 1.5 kilometers. Then you can get slippage of the plates you could have increased earthquake volcanic activity. And again, I mentioned a lot of the different cycles of the gravitational cycles where you have your 12-hour tides, in the ocean, high tides twice a day, every 12 hours. That's the new moon and full moon. New moon and regular moon. And also cycles go out 4 years, 9 years, 18 years. And there's a big 72-year cycle, and we're going to really talk about the 200 to 230-year strong gravitational cycle. We've already discussed the 1200-year one. So this is what the 1200-year electromagnetic gravitational cycles look like, and the strength of them. You can see a sinusoidal curve, and strongest, again, when I showed you the global warming cycles, it was very warm back around 900 AD, and the global warming cycles were less until we got to this one today. And that's because the gravitational cycles kind of correspond to this.
Yeah, I want to interject real quick. This cycle
Yes.
looks a lot like the global warming cycles that you were showing us, like you just said, from 900 AD and moving forward, almost identical. When you look
Just
at these,
about.
yeah,
And this is what I'm going to
Yeah.
do. I'm going to overlay it. There's
jeez,
our global warming cycles, and you overlay it, and there you are. This is what controls the global warming cycles and global cooling cycles. As I indicated, we've had 6 global warming cycles since 850 AD, and we've had 5 global cooling cycles, looking for number 6. And we can't stop it. It will come. It will come. And I'm going to show you a little bit later on, this also corresponds to the solar cycles.
yeah, wow,
Part number 3, we're going to update here on atmospheric concentrations of carbon dioxide. Will carbon dioxide and global warming end the world in 12 years? This is what we were told back 6 years ago. The world was going to die in 12 years. Well, we only have 6 years to go, 2031. Earth going to be dead in 2031? Yeah, right. Carbon dioxide. This has been increasing carbon dioxide since 1960 up through about 2024 to January 2025. So you can see it's a kind of steady increase in carbon dioxide. Well, is the rise in carbon dioxide, atmospheric rise, since 1850 is caused by human activity? Did the burning of fossil fuels add all this carbon dioxide to the atmosphere? NOAA and the International Government Panel on Climate Change says yes. It's all due to fossil fuel. Well, if we take a look at it, there's a few studies that we can look at that will negate the thinking of what they just said.
oh, I love this.
Looking at, there was a study done using plant stomata cells. This is a leaflet of a plant. Inside the leaflet, it has little stomata cells, sort of like the lungs in people. However, the amount of stomata cells change according to how warm or cold the atmosphere is, or how much carbon dioxide is in the atmosphere. Because what the plant leaflet does, it takes in carbon dioxide. It takes it out of the atmosphere. The byproduct is oxygen. That's good. We need that. So what they found is when you have a great amount of stomata cells, that means you need more lung power because you have less carbon dioxide in the air. So you need more lungs to get your carbon dioxide to survive. If you have fewer cells, that means the atmospheric carbon dioxide is high. So they can determine the amount of carbon dioxide in the air over time. And this is what the study showed. The orange line is the carbon dioxide. And if we go back to 800 AD, the study showed that we had 375 parts per million of carbon dioxide. Well, the ice core studies and everything we're told is it's never been above 300 parts per million. Well, that's not what the plant thermometer shows. Then it decreases down to 250, back up, back down to 230, up, down, up, down, up, down, up, down. And in 1850, it's 260 parts per million. And this is what the government agency said. It was 260 parts per million. But the plant thermometer says that in 2010, it was up to 375.
Phew.
But the government says before industrial age, we've never been above 300. Well, that's false. And the sources for what I'm talking about, plant stomata cells, anyone watching this video can stop it and take a look at this, and they can go back and find the research on it. And there's also one on underestimating carbon dioxide and Antarctic ice cores. I'm going to show you that in a minute.
Nice.
That's in the Tom Nelson podcast number 64 that I did back in 2023. And the World Atmospheric CO2, that's a health physics journal. And we're going to go through some of this data now. Okay, NOAA. Since 1850, NOAA says that the rise in carbon dioxide in the air is 100% due to fossil fuel. 100%. Well, my research, and I'm going to show you a little bit more of it, says that no, it's 80% natural. Scrabble et al., that was the physics paper that I showed you the link to, says 80% natural. The plant stomata cell study that I showed you says 80% natural. So is it 80% natural rise, or is it like what NOAA says, 100% fossil fuel? And again, this is the source data. Ice core down in the Antarctic, Lake Vostok, very deep lake, has about 15,000 feet of ice. What they do, they drill down in the ice to get ice core samples and then look at air bubbles within the ice to see how much carbon dioxide was in the air at a certain time. They look at the trapped bubbles. And they go down as much as almost 16,000 feet. Now, the thing is, when they drill down, we have what we call new ice. Air bubbles are not locked in place during the first 5,000 years. That's about 688 feet of ice. So what happens is there's a study out that the ice loses 2.5 parts per million every 44 feet until it becomes locked into place, the air bubbles, which means the ice core samples that they're telling us about has lost 30 parts per million, and they're not telling you about that. So we have to do a correction. We have to add 30 parts per million to the current one. This is a sample I'm going to be showing you. For example, if it was 297 parts per million on an ice core sample, you have to add 30 to it. It was actually 327 parts per million. But they tell you we've never been or never even reached 300 parts per million. That's false. So here's the atmospheric carbon dioxide from ice core samples going back 425,000 years. This is what they showed back 425,000 years ago. We were about 280 parts per million. Then peak of the next interglacial warm period, 297, 278, 287, 296 is what they said. But then NOAA says, well, we're at 425, but that's all due to burning fossil fuels. And I've already shown you that's not true.
Yeah, that's false.
So we put in our corrections on this, adding in the 30 parts per million that got lost due to escaping back into the atmosphere before the ice bubbles get locked in place. And also a correction for 80%. It's 80% natural. It's not 100%. So here's our correction. This is what, red line is what the carbon dioxide should have been. And see, we're going to just raise that right up. And this is what it shows. It should have been 378, 355, 376. And right now, 378. We're at 425 is what they're recording in Hawaii. We're at 378, maybe 400 being natural. So they are way off on what they're telling us, way off. And this is all detailed in the Tom Nelson podcast interview number 67.
Well, and just from personal observations,
Yes.
really carbon dioxide parts per million has been hovering between 418 and 425 for the last 6 or 7 years. So it really hasn't increased or decreased much. It's kind of staying steady right now if you really look back. And a lot of folks are blaming that back and forth of 3 to 4 parts per million being the reason why 2024 was so warm, but that math doesn't add up either.
No. That has absolutely nothing to do with our warm climate at this time. Okay, this is a part you particularly like, is solar cycles and climate change. And this is a graphic that I just found. The yellow is the solar cycles, solar activity from about 1880 up to, I guess, about almost 2020. So you can see the solar cycles, there is a big peak in it in the 1950s. Now, the red line is what the government says, this is from NASA.gov, is the global temperatures. And you can see starting in 1880, it goes pretty good with the solar activity, up and down, up and down. Then what happened here around 1940 to right around that area? Big jump in global temperatures. Well, that is because both the Atlantic Ocean and Pacific Ocean was in a warm ocean phase for water. Okay. And I'm going to show you that. So that kind of skewed their data to make it look like it didn't conform with solar cycles. And that is totally untrue. And then it went back again as the water cooled down. It conformed more, started to warm up again with the solar cycle. Then I had this circled in blue. Both oceans have been in the warm cycle again, the warm ocean phase cycle. And remember, the previous graphics I showed you, this is how they determined the Earth's temperature.
Right,
71%. 71% of the surface of the Earth is ocean. And 29% land. So they add it all in, average it out, and this is why there's a big discrepancy here. Okay, solar cycles again. On this graphic, starts at 1610 AD, and we're going to shoot up here to the 1700s. And what we see here, this is solar activity, big increase of solar activity, 1725 to 1790. That's the solar insolation on the black line. And then it dropped off, peaked up a little bit, short period, mid to late 1800s. It dropped down again as cool weather, but then warmed up again. This is our current global warming cycle. Now let's put in the world temperatures. This is what we show in the world temperatures. It conforms with the solar cycles. Warm in the late 1700s, cooled down, warmed up a little bit, cooled down, then our big global warming cycle that we're in now, global warming cycle number 6. And that is about to end, the solar cycle. So we should start seeing a big dip in the solar cycle readings and also the world temperatures. We should be going into a global cooling cycle. Next global warming cycle, number 7, will be way out around 2100, 2150 to 2190, somewhere in there.
Yeah, it looks like your chart
Yes.
got us starting the deep part of the cooling anyway is in the 2040s, which during the 2030s, we're going to see that declination all the way down in temperatures across the globe. So this is just blowing my mind how many certain cycles are matching up, and they're all saying the same thing. Go ahead, David. I'm sorry.
They are. Everything is matching up, and I'm even going to show you something else that will match up here in a minute. And also on the solar cycles, what does it do to the high Arctic? Well, this is something I looked at, temperatures in the high Arctic. The blue line is the long-term average temperatures for the Arctic. And what I have in the shaded blue area, that's the spring and summer months. During 2022 and 2023, the temperature in the high Arctic, that's the orange line, was pretty much average to below average during that time. I'm saying, I look back to when records began in 1958, the 2 years, 2022 and 2023, were the coldest spring and summers on record since 1958. And that shows that something's starting to happen. The solar cycle is starting to diminish, and the high Arctic is starting to cool because the solar activity warms the high Arctic air. But one thing that happened, though, during the later part of 2024 that just ended, we had a big increase in solar flares. We saw that during the summer and fall to early winter. They were talking about, oh, you can see the northern lights here and there. Well, we had a peak.
Right.
We had a little flash peak in there. So that warmed the high Arctic again. This is why when December ended, the high Arctic was quite warm. But what I'm seeing now during January, as the solar flares have diminished, look at the temperature. It's almost down there to normal. It's cooling down again. And that's going to be reflected during the next several years. As you said, Jake, we're going to be going into the Maunder minimum. And this is going to have a big effect. Ocean temperatures. Big changes coming. I showed you before, this is the ocean temperatures, January 2025. That's the little La Nina that's going on the equator in the Pacific Ocean. Otherwise, look at this. The oceans are very warm. The yellow is above normal temperatures. Dark orange, red, extremely warm. So you can see the oceans are very, very warm right now. Very warm. But we're going to see some big changes. The Pacific Ocean has a oscillation. They call it an oscillation. Put that back. It cycles. This is from the year 1500. That's a long time ago, 1500. What we see is oscillations where it warms up, cools down. Look at this. Warm, 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 cool, warm, cool, warm, cool, warm, cool, warm. And the latest cycle we're in, still in it, started in about 1981, and I expect it's going to be ending right around that 2025 here, probably in 2029. They'll be going into their Pacific cool water phase, and that's going to really hit the Climate Prediction Center when they average in the ocean water temperatures for the Earth's temperature. Because after 2030, it's going to be cool water. And the Atlantic Ocean also has a cycle. This goes back to about 1870 to about 1900. The Atlantic Ocean was very warm. Then it cooled down. Then we had another warm cycle again. They come about every 70 years, cooled down. And we're still in a warm water phase that began in about 1995, and this should be ending right around 2030. We'll be cooling down into a cool cycle. So what's it all mean? Well, first of all, we're going to have a strong El Nino in 2027, 2028. When you have a strong El Nino, the water temperatures along the Pacific equatorial area warm up, as noted here in the red. So the Pacific Ocean will be warm. But this is going to be followed by what we call a La Nina. That's the opposite, where the equatorial water temperatures get very cold. This is going to happen in 2029 and 2030. We're going to have a very strong La Nina. So we're going to see a big change in the water temperatures. So here we are, a graphic. This is November of 2023, warm waters. Well, there's the strong El Nino we're going to have in 2028. Warm up the equatorial area. Could be really warm.
Wow.
Then, strong La Nina, 2029, 2030, going to cool it all down. And we're going into the Pacific cool phase, water phase also. That will be cooling down the Pacific Ocean.
Jeez.
The Atlantic Ocean is going to go into its cool water phase in 2030. That's going to cool down the Atlantic Ocean.
So this was the
yeah.
predicament you were talking about that Weather Prediction Center is going to have by 2030. All of these cooling cycles that are going to be forming across the globe.
That's right. If they add in all the oceans on to the land, we're all of a sudden we're going to have cooler than normal world temperatures around 2030, 2031. So what I'm saying is global warming will be dead in 2030. It's going to be dead. And because this is all changing. Everything's coming together. The solar cycles, electromagnetic, gravitational cycles, and the ocean cycles. Okay, and we're heading right into the climate outlook, 2030 into 2021. Well, for global warming, and it comes every 200 to 230 years, global warming kind of begins in the Arctic as the Arctic warms up. When the Arctic warms up, you have less real cold air to filter down into the mid-latitudes. So the mid-latitudes warm up, and there you are, you have global warming. Well, global cooling also begins in the Arctic. 2022, 2023, coldest spring and summer on record in the Arctic. We're going to see that again next winter. So the Arctic will be cooling down, and that will help to cool down the mid-latitudes. And that in conjunction with the cooler oceans coming in 2030, you're going to have global cooling. And this is our global warming cycles, go back to 900 AD. Global warming cycle number 1, 200 years after that ended, the next global warming cycle ended. 240 years after that, the next global warming cycle ended. And it goes up to 200 years again. 200 years after that, warming cycle ended. 230 years after that, it ended. So you can see it alternates 200 to 240, 200 to 230. So it's going to alternate up to 200 years for the ending of the global warming cycle number 6. Well, the last global cooling cycle began in 1825, or I should have that as 30, I'm sorry, 1830. 1830 plus 200 equals the year 2030. So everything is coming together. Everything.
Yeah.
And global warming will be dead in 2030. And this is, as my helper here said, instincts.
He did a good job.
Use common sense, and that's exactly what we did. Common sense. And that is it.
David, this was excellent information. The 2030s are so important, and we've had other YouTubers and other private researchers who've also have been concerned with what we're going to be facing when we get to 2030. As we've said since we started this channel, the cooling doesn't happen overnight. This takes some time. This is part of that research as observing as time goes by, but it really does look like everything is going in the same direction, and that is a cooling trend. And I think the one thing that really sheds light on where we're going to be at, when you had the chart that said that 2042 was the start of this current cooling cycle towards the bottom, well, that makes a lot of sense too, because that'll also be the heart of the grand solar minimum. We're going to be right smack dab in the middle of a grand solar minimum by the time we get to 2042. So temperatures will even feel even colder by that time.
That's right. That's why I had 2040 on there. Is it took 20 to 30 years really for us to really get real warm peak on our global warming cycle during the late 1900s and 1900s. Yeah, I mean around the year 2000 to 2024. It took almost 24 years.
All right. So we watched a couple of videos showing a lot of correlations between solar cycles and these ocean temperature cycles and all the other cycles that David showed us. So, and the purpose, again, like I said, there is a claim out there off of one paper that suggests that the tide has turned. Well, folks, I'm here to tell you, like I said earlier in the broadcast, Mari has been in recent contact with Valentina Zarkova. There's no update coming for her prediction. The grand solar minimum is still on. There is nothing that's changed from that. And with that said, I'd like to thank everyone for tuning in tonight, or this afternoon, I should say. A lot of familiar faces out there in our chat today. Knife Collector, our good friend up here in the Northeast, along with Summer BC, Wood Spirit, good to see you. Melody, also out there, nice to see you. And many, many others out here. Melody, bunch of people that I have seen in here. Lisa B. So we appreciate you guys' support, sticking around. We know we don't broadcast as much or as recent or as often, but we do have some loyal folks out there who continue to follow this channel. So we appreciate you allowing us to be your Grand Solar Minimum News official channel for the Grand Solar Minimum News. In fact, nobody else is covering the Grand Solar Minimum except for us here at the Grand Solar Minimum channel. A lot of folks, when they see things that are a wrench in the plan, it makes them nervous, and they jump out. They jump ship just because there's a little hiccup here. And Solar Cycle 25 is still not that strong. So I think you'll see. Oh, Vert Caber, good to see you as well. But I think you guys watching the Valentina interview, watching the David Dilley interview, that is a consensus from two different types of research that is pointing at global cooling by 2030. And we all know that number 2030 has been thrown around for quite some time, and it's always been the plan. When we said the grand solar minimum started in 2020, we just meant it started. It doesn't mean all of a sudden blizzards every day in June or anything like that. I mean, it takes time to get into the whole full swing of things. By 2030, there won't be any doubt where we are in global temperatures, where we are in solar activity as well. So it's going to be an interesting ride, folks. Trust me on this. Or actually, you don't have to trust me. Just look at the research for yourself. And I've already pointed out several flaws in the article on the Watchers that talks about this research about the South Atlantic anomaly and how proton influx was increased during that. But they never once mentioned that the magnetosphere had a hole in it. It collapsed, basically. And that's why the influx of the protons increased. Not because not because the minimum cycle's over by any means. All right, folks, that's going to do it for us. Thanks for tuning in once again. We hope everyone has a great weekend, and we will talk soon.
Do you like this show? Give us a thumbs up. Want to support us more? Share to your favorite social media platform. Buy a t-shirt or become a Patreon. All links